Hello, everyone. First of all, I want to say thank you for having me here on AppSec 2020. Even though this is not how I imagined it would be, this is definitely a dream comes true. Today, I plan on giving a talk about a research I did, which resulted in a number of very serious vulnerabilities in WhatsApp's platform. Even though that is very interesting by itself, the insights I've gained out of this research were almost as profounding. This talk will mostly be about me trying to walk you through my research, but its most important part would be the key takeaways, the one I will present at the end of the talk, and the conclusions I made out of each of the different achievements throughout the research and how they reflect on the security aspect of web-based messaging apps in general. So let's begin. But first, let me introduce myself. My name is Weizman. I am 26 years old. In contrary to the rest of the world, my career started in my military service in IDF in Unit 8200, which is known as one of the biggest Israeli cyber technology units, where I was originally trained to be a QA of cybersecurity products. Working with the best in the field, I was fortunate enough to learn a lot and later on to advance the development of some minor cybersecurity related products. Those products were web-oriented, and this is where my passion for offensive and defensive web security has begun. After achieving some great goals in the field, my military service has come to its end, and I started my first tech job as a civilian. I worked as the first employee for a small company called Apponit, which was founded by 5 talented guys who were also veterans of 8200 units. Apponit had a product which helped recovering ads lost by AdBlock, by implementing sophisticated web security concepts with which they were able to bypass it. This job was a serious jump for me in the field of web security. Thanks to the complexity of the challenges we had to deal with, I managed to make a great leap professionally-wise. Separating from Apponit a year after, I decided to travel the world for a bit more than a year. Surprisingly enough, this will actually be part of the story I'm about to tell of how the research of WhatsApp has started. After the travel, I came back to Israel and started working for Perimeter X as a web security researcher, and still do for the past 2 years. Perimeter X is where I made another great leap in my professional level in the field of web security, as the company tackles the hardest security issues in the field and wishes to solve them and make our experience on the web more secure. While working for Perimeter X earlier this year, I published a thorough research I did for months, demonstrating several critical vulnerabilities in the platform of WhatsApp. I would like to take you step by step through my research and show you what it taught me about the security aspect of WhatsApp, but also about the security aspect of web-based messaging applications in general. So let's begin. So the year was 2017. After a month of traveling through South America, I realized that traveling is too much fun for a short 2-month trip. And I decided to purchase a laptop in order to continue my technological development while being abroad, hoping to maybe get a remote job later down the road. By that time, I was very much into web security, and occasionally I had these random ideas of researches on ways of breaking web applications. So I thought having a laptop with me could be a good use of my time while traveling. 3 months into my travel, while I was in Peru, an interesting idea came to my mind. So I'm no native mobile applications expert, but with my knowledge in web research, maybe I can make WhatsApp behave funny by manipulating its actions via the WhatsApp web platform. This led me into trying to manipulate messages before they are sent. And the first thing I managed to achieve is to fully control the text in a reply message. Quick side note, pay attention to the different achievements throughout the talk, because we will be covering them at the end of the talk again. So all I had to do is to change the text of the reply property of the message object before it is being sent, and then let the message fly. By doing that, you get the following unexpected behavior. A reply text of a message that never existed. So by manipulating this object, the object at the top, and changing the text like I did in the middle, you get the fake text that you can see at the bottom. So I may have used this to prank a couple of my friends, but I didn't have any idea at the time of how to turn this into an actual security flaw. From this point, my research kept going on and off, since after all, I was in the middle of my travel. Sometime after, I learned that Checkpoint Company have published this finding as well, but I wasn't bothered about it because I couldn't see the severity of this flaw. So I left all that and I came back to focus on traveling. After traveling for over a year, I came back home and immediately started to work for Perimeter X as a web security expert. A year into my job, 2 years after my first finding, another WhatsApp-related thought came to my mind when I was looking at a reach preview banner message. But in order to continue from this point, we must understand what reach preview is. So you know how you insert a link to a post or a message, and all of a sudden that simple link turns into this cool banner with an image and some text regarding the website? That's reach preview. Each HTML page may contain special HTML tags called meta tags that provide standard information regarding the web page that applications may use to enrich provided links with. So for example, since Facebook.com's meta tags look something similar to this, their rich preview banner will result in something like this. While we're at it, and before we continue, this GIF in fact contains the problem that most of my findings rely on. Take a second to think about what it might be. What problem is demonstrated in this short GIF? The banners are generated on the sender side, or in other words, the potential attacker side. This is a recipe for trouble, because when you think about it, I can apply the same technique I did on my first achievement here as well. When WhatsApp Web generates the preview banner, there are new properties to the message object, and some contain the URL from which the rich preview was fetched, which is where clicking it will redirect you. So the idea is to simply mess with the message object, as I did before, and see what I can get from playing around with the rich preview properties of it. I learned that by changing the URL, I can get a preview banner that looks like Facebook.com, but will redirect to example.com when it's clicked. This can be extremely dangerous as a very efficient phishing method. And the result is this. There's a banner right there. And when you click it, you get to example.com, even though it looks like Facebook.com. Here's the demo. As you can see in the demo, right before sending the message, I change its URL. And when I click the crafted banner, I am being redirected to example.com instead of Facebook.com. And there we go. And in order to create a more reliable crafted message, I can modify the URL to a valid one that will redirect to any link I want while still looking like a legitimate Facebook.com URL by using some URL tricks from the official spec. So this is how it looks like. And for those of you who are not familiar, anything before the @ sign will be handled as credentials, and what comes after it is the actual URL. In the picture, I used bit.ly to redirect to example.com in order to avoid having the true destination URL visible in the message. This is crazy dangerous because this looks like a legit Facebook URL. Sending this to tons of random WhatsApp groups and having it linked to facebook.com lookalike phishing site can result in theft of a lot of Facebook accounts, for example. So wait. If I can replace an HTTPS URL with another HTTPS URL, can I use different schemes as well? This is where things get to the next level. I tried to replace HTTPS facebook.com with JavaScript alert document.domain. And well, the bad news is that it didn't work. But the good news is that the reason it failed is due to a check that can easily be bypassed. At the time this vulnerability was open, after some research, I learned that WhatsApp Web verifies two things. First, the existence of the URL in the body of the message. And second, the existence of a URL that begins with HTTPS in the rich preview banner URL property. Meaning, all I have to do is make sure that A, my JavaScript URL is contained within the body of the message, and B, my JavaScript URL contains a valid HTTPS URL within it. So by simply doing this, I can successfully inject a JavaScript URL, which will result in an XSS. There you have it. It is important to mention that when I worked on this, Chrome's version was 78, and at that point, they implemented a defense mechanism against the opening of unwanted JavaScript links. So this did not work on WhatsApp Web on Chrome when I found this vulnerability, but it did work on Safari and all Edge browsers. This point will meet us further along the talk as another point of failure in WhatsApp. So why is this so dangerous? Well, first of all, this is a cross-site scripting. This gives anyone the ability to freely run code in anyone's logged-in WhatsApp context the second they click this type of malformed message. And once attackers have gained cross-site scripting abilities, they can do pretty much anything they want. They can steal messages, images, audios, and more from the victim. They can take actions in the name of the victim, such as sending or deleting content. An attacker can even use this vulnerability to spread a worm that when it's clicked sends itself to all of the victim's contacts and steals all of their personal WhatsApp content, for example. This is really bad. This is perhaps a new type of the most critical version of XSS, a client-stored XSS, as the XSS is stored within the message, which is stored in and loaded by the victim's phone. Most would say this is as bad as it gets, right? Well, not me. I wanted to prove I can leverage the XSS I found into a real-life scenario. Attackers would have had a hard time weaponizing an XSS when they cannot dynamically change the actual payload. In other words, if attackers want their payload to alert a message, for example, they would preferably want to control the content of the message remotely instead of hard coding it into the malicious message. Meaning I had to craft a message that loads the JavaScript payload from an external address and then executes it. Now, I know what you're thinking, a simple script element should do the trick, right? Well, not this time. WhatsApp Web configured a clear content security policy that prevented me from easily loading an external script. I had to find a way to bypass it. But how does one bypass CSP? For me, the easiest way to bypass a CSP is to use the great tool called CSP Evaluator, which, when provided with a link, can tell you how well configured the website CSP is. By inserting web.whatsapp.com, this is what I got. See that object src missing directive down there? This is the vulnerability I was looking for. I immediately learned that their weakness is with the object src CSP directive. It is not configured. This means I can fetch JavaScript and evaluate it using an object element, and by that to fully bypass the configured CSP of WhatsApp Web. So this is what I'm going to do. What I'll do is I'll use an object element as an iframe and load a cross region window while registering a message listener awaiting JavaScript code to evaluate. That cross-region window will be to a server controlled by me, which will serve a simple HTML that posts a message with the JavaScript content to evaluate. That way, I can change the content whenever I want, since it is served by a server I control, and be sure my malicious static message will always know how to load this dynamic payload, even when it's changed. This, in fact, allows me to update my attacking payload whenever and however I want without having to re-invoke the malicious message every time. This really takes the attacking vector to another level. This can truly serve attackers. So this was it for me. I managed to create a perfectly looking dangerous phishing messages, and even worse, messages that fetch external payloads and executes them under web.whatsapp.com when clicked. Unfortunately, the impact was destined to be considered by Facebook as less major, since this didn't work on the latest Chrome nor Firefox, but it was still pretty impressive. So after deciding that this was impressive enough to submit to Facebook, I worked on my disclosure documents in order to hand them over to Facebook. I went over to the report a security vulnerability UI and selected WhatsApp as the vulnerable product. I was then asked to select the product's type. My options were web, iOS, Android, and then Windows and Mac. I didn't even know Windows and Mac are options. What does that even mean? Well, a quick lookup on Google is how I learned for the first time that there is a desktop version for WhatsApp. I didn't even know. I had to relax my enthusiasm to finish my disclosure in order to run one last quick look, just to examine my finding on this new WhatsApp platform I just discovered. In my head, I was very skeptical. Why would a web-based vulnerability work on a native desktop application? I was ready to see it fails for myself, get it over with, and file a disclosure already. After downloading and installing WhatsApp Desktop on my private Windows laptop and logging into my WhatsApp account, I clicked the XSS message and I was just shocked to see this. An alert popped. How is that even possible? Isn't this native app? And what is this funny looking alert message? At this point, I had to pause the disclosure process and learn more about what just happened here. So another quick lookup on Google is how I learned that WhatsApp Desktop is built using a technology called Electron. For those of you who are not familiar with the concept, it is a Chromium-based platform that lets you take a website built with standard web technologies such as HTML, CSS, and JavaScript and turn it into a native application, sort of. So the alert is empty probably because document.domain is an irrelevant property under Electron circumstances, but the alert itself sure did work. But if it is Chromium-based and the latest Chromium blocks JavaScript URLs loading, as we said before, then how come the XSS works? Well, I updated the external payload to alert navigator.useragent and was both thrilled and disappointed at the same time to see the following message. Can you see the problem? The next vulnerability in the story can be understood from this picture, so take a couple of seconds to try to find it. The latest WhatsApp desktop app ran Electron Major version 4, which is based on Chromium 69, whereas the latest Electron version was Major version 7 at the time, which is based on Chromium 78. This means WhatsApp were distributing an old and vulnerable version of Chrome to us, their users. I immediately realized the potential impact in the very odd fusion of having an XSS on a native app and tried to prove I can use this to access local resources on the machine itself. So by fetching the following external payload, I managed to obtain the content of the local system host file, as you can see here. This is such a major escalation. Not only I used XSS to run code under web.whatsapp.com, I can now use this code to access the file system of the machine that hosts the WhatsApp application. Unfortunately, I did not take the time to prove this, but theoretically, obtaining an RCE should be possible at this point based on the fact that there were more than one publicly disclosed RCE vulnerabilities that were patched only after Chrome 69 and could be fully exploited via JavaScript code execution. The implications of a scenario where RCE is possible could have been huge. Attackers could have used these exploits to spread a ransomware worm that, when it's clicked, sends itself to all contacts and encrypts file system entirely, demanding the victim to pay for the decryption key, or steal content or passwords that are saved on the local computer, or even install a spyware. However, the RCE part was never proven and therefore remains theoretical. But still, the implications of the proven read from the file system ability are enormous. So this was it for me. From a reply text fabrication to a simple yet powerful open redirect through a client-stored XSS, both on web and desktop, to a CSP bypass, all the way to a read from the file system ability with a theoretical potential for remote code execution. This is how my research has come to its end. I reported all of these flaws to Facebook and was granted with an appropriate bounty, and this was the end of the adventure. The research journey is over. So why am I telling you all this? Well, first of all, I wanted to give you a peek into how web applications hacking looks like in 2020. I wanted you to learn how fun and interesting it could be and how thinking like a black hat can really help in the process of research. But I also wanted to stress how dangerous such vulnerabilities can be to us, the users. Messaging apps contain the biggest amount of information that we would consider as extremely private. I'm talking about pictures and texts we send to each other on a daily basis. We tend to feel very safe there, but abusing such vulnerabilities might shatter the illusion, and once it does, it can be very unpleasant. But messaging apps are not going anywhere. And if that's the case, the least that can be done is to work hard on making our experience safer, which is what we as users expect from the vendors of those apps. And this is another reason why I'm telling you this. I want my research to not only be a cool hacking journey, but to be a string of lessons passed on to the messaging apps vendors to be used to enhance the security of these products. So let's go over the different achievements that were gained in the process and make sure we learn from each and every one of them. So my first achievement was to successfully fabricate the reply text of a message. Protecting this should be quite easy. Simply rely on the ID of the reply message instead of its textual content. Invalid ID, invalid message, as simple as that. Then have the receiving side do the link to the reply message. This should not be in the hand of the sender. My second achievement was the open redirect. Now this is a tricky one, because on the one hand, you don't want the link to be fetched on the receiving side. Otherwise, attackers could exploit the fact that they control the content that is prefetched by the victim when their device preloads the link. But on the other hand, you don't want the link to be fetched on the sending side. Otherwise, mitigating the open redirect issue presented in the achievement would be almost impossible. So in my opinion, the best solution would be to let the server in the middle be responsible for constructing the preview banner based on the received link in the message. In general, links fetching and loading should take place in the server of the messaging app, not by any of the end users. My third achievement was to successfully replace a legitimate HTTPS banner with a JavaScript banner, thus obtaining XSS. Validations are the responsibility of the receiving side, much more than the sender side. When a message is received, the receiver's end responsibility is to go over all the links in the message and get rid of all schemes that are disallowed, such as JavaScript or data or blob, and so on, because you simply cannot trust the sender. Maintaining an allowed list would have been ideal if schemes options were not infinite, but every app can register its own made-up scheme, basically, so that's not an option, unfortunately. My fourth achievement was to bypass the CSP to successfully communicate with the attacker's server, thus maintaining a successful attacking vector. CSP is also a tricky one. The world failed to adopt CSP as a web application security layer. We understand it now. After years of failing attempts to integrate it, not many companies have correctly implemented CSP. In fact, most companies either wrongly integrate it or don't integrate it at all. In another article I published a few months ago, along with a full CSP bypass 0-day vulnerability in Chromium-based browser, I talk just about that. I talk about the problem with CSP and why it is so poorly adopted by the world of web, based on another research I did around the CSP bypass vulnerability I found. Well, ideally, I would expect the messaging services, along with the rest of the world, to harden their content security policy. But since CSP's history taught us that that's not going to happen, I suggest integrating external services that monitor and display web pages' behavior in a much closer resolution than CSPs. Such products like Perimeter Access Code Defender can detect such attacks without necessarily blocking them. thus providing a clear image of suspicious behavior in web pages, along with a lax policy configuration. Any of these choices is fine, but not taking the problem that CSP or Codefender come to solve seriously is simply unacceptable, as it leaves us vulnerable. My fifth achievement was the ability to load the JavaScript URL due to WhatsApp desktop being based on a vulnerable version of Chromium. This one is super important, and it is the most basic rule in software shipping. Never distribute applications that are based on technologies that are publicly known to be vulnerable. If your product is based on a certain technology that was discovered to be vulnerable, you must update it and release a patch version immediately. Otherwise, you leave your users in clear danger due to pure lack of responsibility. I reported the issue to Facebook on December 2019. At the time, their latest WhatsApp desktop was based on an 8-month-old Electron version. Never let this happen. When your dependencies update, your product has to update as well. My sixth achievement was the ability to read content from the file system. Cross-site scripting is one thing, but that doesn't mean basic JavaScript code in the web page should have permissions to access file scheme URLs. In other words, take risks under consideration when granting privileges to different parts of the app. If someone managed to execute JavaScript code in your application, what's the biggest damage they can cause? Keep asking and answering yourself that until the answer is as close to nothing as possible. I want to quickly recap the different parts and conclusions of the talk before finishing up, just to make sure you take something out of this talk with you apart from the entertainment itself. So for the hackers and the researchers, you can still find hardcore XSS vulnerabilities in top-tier services, even in 2020. Look them up. Responsibly disclose them to the vendors of the vulnerable apps. Help protect us in the most intimate technology we use on a daily basis. Think like an attacker. It is very hard to find such severe vulnerabilities while thinking like a defender. For the messaging apps vendors, carefully manage the privileges you grant to the different parts of your app. Either harden your CSP or integrate an enhanced behavior monitoring solution, but please make sure this layer of security is taken care of. Validate the content that is sent on the receiving side before you present it to the receiver. Do not ship applications that rely on dependencies that are publicly known to be vulnerable. We love messaging apps. They're amazing. They made everything better, really. We are glad to support you by using your products, but we ask your support and respect to be mutual. Take our need to feel safe when using your product seriously, and embrace the points listed above to your products in order to better secure us. And for the users, both the breakers and the builders, we're doing our best to make sure you are as safe as possible when using your favorite messaging apps. Learning that you were exposed to such vulnerabilities can be disappointing, but bear with us. Fully securing such complex apps is a process. We're getting there. Oh, and one more thing, be very suspicious before clicking links. Even if received in your favorite messaging apps, you have just been proven how links are still not perfectly safe, even in 2020. I hope you enjoyed this talk, but more importantly, I hope you will take something with you out of it. Oh, and remember, always travel with a laptop. Thank you.